Hey, welcome back. All right, so we're now on to lesson 39, more consecutive integer problems. Our second day, again, should feel more and more comfortable as we move on and as we do more practice with these. Remember, I always like to start with some real life numbers and then kind of go into the algebra a little bit from there. So let's read this one because I'm looking for what error did they make? My favorite types of questions. A class writes the equation n plus n plus 1 plus n plus 2 equals 87 to solve the following problem. The sum of three consecutive odd integers is 87. Find the three integers. What error did they make? So they made a mistake. What did they do? So when we talked about consecutive integers, we specifically kind of like wrote three, especially if we're talking about three numbers, we wrote three numbers on the side to help us with our let statements. In this case, if I'm talking about odd numbers, I need my three favorite odd numbers. I always go to 3, 5, and 7 like we did in yesterday's lesson. And then I'm going to write my let statement. I'm going to write my first number, second number, third number. And I always start with x. So x is always my first one, and then I'm going to move to the next integer, thinking about what rule I have to use to go from here to here. My second one would be x plus 2. And then my third one, how do I get to that third number? Using x. I'm going to have to add 4. Now right away I can see that's not what the class did. So it seems like maybe they used consecutive and just forgot the word odd. That's possible. And then what they should write, again, we're talking about sum, so sum means to add, so they definitely did that. I would write, they used n, we use x's, no big deal on that. You can use any variable you want. The sum of all three of those is 87. And that's what ours would look like. So what error did they make? They did not use odd integers. So there you go. And again, just like what we did yesterday and in the lesson from the other day, you should then look at this, try to simplify this left side first, and then follow our rules for solving to find the three answers. Again, it's always a good idea to have your let statements here because it's a great place to put your final three answers. Alright, that's all you need for this example, and then we're going to do one more model problem together. Again, just a good practice, and then we'll be done for the day. So be sure you have all these copied down. Alright, so let's give this problem a try. This one says, find three consecutive odd integers, alright, so I'm going to underline that, such that the sum of the first and third equals, I'm just going to underline some keywords here, the sum of the second and 43rd, and 43. That's weird. Alright, so before we get into this, which sounds very confusing to me, and definitely is going to be worth a second read, I'm going to start with just this part. Remember, just from this statement, what I'm finding, that will help me set up my let statements. Because we're talking about odd numbers, I'm going to pick my three favorites, 3, 5, and 7. And that will help me first, second, and third set up my let statements. Remember, the first one's always going to be called x because I don't know any of the numbers. So if I don't know anything, the first one at least is going to be x. But then there's a pattern, right? And using my three example numbers, I can see the pattern very quickly. To get from 3 to 5, I have to add 2 more. To get from 5 to 7, I also have to add 2 more. But I can't just write x plus 2. Because remember, x represents that first number. So it's really, how do I get from this number to this number? And that's really adding 4 more, right? We add 2 each time. Okay. Remember, this is a great place to kind of draw an empty box. There are 3 answers to this problem. Depending on if they want all 3 answers or not, that's up to them. But at least I have a place for all 3 answers. All right, now I'm going to reread this mess because this sounded a little confusing. Find 3 consecutive odd integers, here they are, such that the sum of the first and third equals. All right, so let's take that apart first. When they're talking about first and third, this is what they're talking about, first and third. So the sum, we know what sum means to add, of the first and the third. So I'm going to take the first number, which is x, and the third number, which is x plus 4, and I'm going to add them together because that's what it's telling me. The sum of the first, right, first and the third. Okay, so sum of the first and third equals, okay, now I'm up to the next part. The sum, again, sum of the second, so second we're talking about this guy, second, x plus 2, and 43. So the sum of x plus 2 and 43. So 43 is just coming from the word problem. Again, we have that word sum, which means add, and I have the second, and I have 43. All right. So again, one more time, and I do like to read it a few times. Find 3 consecutive odd integers such that the sum of the first and the third equals the sum of the second and 43. All right. Whew. I'm going to just rewrite this without all that writing underneath it, but it's a good idea since this is our first problem like this to be sure you have all of those jotted down the way I have it up there. All right. So now I'm noticing a few things, and again, anytime you look at an equation, you're like, all right, I'm ready to solve it, you have to do these things. Take a look at what the problem is. What kind of format is it in? Do you have to do some simplifying? Obviously, I'm going to have to do some simplifying on both sides because these sides are not kind of like all compacted together. What I mean by that is, you know, I have to add all the like terms together. I'm going to add in some coefficients just to help me. I'm going to add just these two guys together just to keep the left side. Now the left side looks a lot better. I just kind of combine the like terms. Over here, I can't combine that 1x with anything, but I can combine the 2 and the 43. So it's a positive and a positive. So this is going to equal 1x plus 45. Okay. Now, since both of my sides are equal, you should also recognize that this is a split variable equation, meaning the variables are on both sides. The equal sign is splitting them apart. So in order to solve that problem, I'm going to move my one variable to the other side. When I move something across the equal signs, I have to use inverse operation. So this is a positive 1. I'm going to have to do minus 1x on both sides. What I have left looks like not too bad at this point, is a one-step equation because x is technically all by itself except for this 4. I'm going to undo that by minusing 4 on both sides. And my final answer, x equals 41. But wait, right? Why did I draw these boxes? Because my x goes here, but then I have to add 2 to it. 41, 42, 43 is going to go in the second one, and then 2 more after that is going to be 45. So all they're asking me to do is just find the 3 consecutive odd integers. So I found them, they're here, and you know what? That box is good enough for me. Its answers are boxed off. So be sure you have all of this copied down in your notes, and we're going to come back to class and work on some of these types of problems in class. A little bit harder to translate, but will be easy to solve when you're there.